All right, this is section 1.5, the PowerPoint voiceover. Linear equations, functions, zeros, and applications. An equation is a statement that two expressions are equal. To solve an equation in one variable is to find all the values of the variable that make the equation true. Each of these numbers is known as a solution to the equation. The set of all solutions is called the solution set. Here are some examples of equations in one variable. Now, I mentioned here three things can happen. You can get a single answer. You can get multiple two or three answers, depending on the degree of the equation. You could get no answers at all. The equation could not be solved. There's no solutions. And the third thing that could happen is that every number, from negative infinity to positive infinity, every answer is a solution. So we'll see examples of each linear equation. We've seen this in the form of mx plus b, where m is the slope and b is your y-intercept. Equations that have the same solution are known as equivalent equations. For instance, the equation 2x plus 3 equals 5 and x equals 1 are equivalent because 1 is a solution of each of these equations. Whereas, on the other hand, x squared minus 3x plus 2 equals 0 and x equals 1 are not equivalent because if I solve this second degree equation, I get two solutions, 1 and 2, but 2 is not a solution to the second one. So since 2 is not a solution of that second equation, these guys are not equivalent. They don't have the same answers. We know solving equations going back to intro algebra, you can add the same value to both sides. A plus C is the same as B plus C. If A equals B, then A times C is equivalent to B times C. And what's not listed here is you could divide both sides by the same value. A divided by C would be the same as B divided by C. And also you could subtract the same number on both sides. Whatever you do to one side, you need to do the same to maintain the equality. Addition, multiplication, what's not mentioned here is the subtraction and division rule. Is an equation that's got fractions, and fractions cause problems for people, but the easy way around this is to negate the denominators by solving for the lowest common denominator. In this case, the common denominator for 4 and 5, lowest common denominator is 20, multiplying both sides of the equation by 20, distributing the 20 with both terms inside, combining like terms, adding 20, and then finally here dividing both sides by 15, reducing the lowest terms. You get an answer of 16 fifths, which could be expressed as 3 and a fifth. Most likely we don't do that normally, but you could express it as 3.2, another way of doing it, but it all depends on how your answer grid is set up. What's nice about solving equations in mathematics is that we can always check. Go back and take the original equation and in place of x, substitute the value you solved x to be, in this case 16 fifths. Doing the algebra, the left side works out to be 7 fifths, the right side was obviously 7 fifths. That's a true statement, therefore it tells you that your answer 16 fifths was indeed the correct solution to this first degree equation. Here's a special case. If I look at this equation, I see a minus 24x on both sides, 7 on the left and 17 on the right. If I start out by adding 24x, I've added it on the left, I've added it on the right, I end up with 7 equals 17. Well, that's a false statement. 7 never equals 17. What this is telling me, what this is symbol of, is that no matter what number we substitute in for x, we get a false statement. All right. Thus, there is no solution. There's no answer to this equation here. No solution. 7 never equals 17. Another special case here, if you look at these examples of these two equations, and you start out by here again adding 1/3 of both sides, you end up with this constant 3 equals 3. Well, 3 equals 3 is always a true statement. And what this tells you is replacing x with any number would give me a true equation. Thus, any real number is a solution. The equation has an infinite many solutions. The solution set is a set of all real numbers such that x is a real number, or in interval notation, your solution set is from negative infinity to positive infinity, any real number. Substituting any number for x, the left side would always equal the right side. An input c of a function f is called a zero of the function if the output for the function is 0 when you put in this value of c. What you're actually doing here is calculating the x-intercept. Find a zero. Well, in place of my f of x, in place of my y value, f of x and y are synonymous. I'm going to substitute f of x. I'm going to substitute in 0 and solve for this. Hey, what's the x value and my y value is 0? It's adding 9 to both sides and then dividing through by 5x is 1 and 8 tenths. All right, we could conceivably use the AS feature on the table set. And I have a special video in Canvas that shows you how to do this. But in this particular case, this equation is so simplistic, you wouldn't need to use the AS feature. All right, that's what it would look like, and I'll actually show. I actually published a couple of videos, or a video on using the AS feature. Another way of solving this, if you're using your calculator, is use the variable Lavar's menu. And here again, I've got a special video on that. A third way you could have graphed this, my gosh, a lot of work here graphing this, and you'll see that the x-intercept is indeed 1 and 8 tenths. All right, you would solve that when we get to this section where we're solving using this calculator feature a little further down the road in the course. I'll have videos that will show you how to do this, how you zero in on the x-intercept, the root of the equation. All right. In this case here, we knew the answer was 1 and 8 tenths because we solved this algebraically. We didn't have to use the ASK menu. We didn't have to use the VARS menu. We didn't have to graph this. It was a simplistic equation. And that is that. I hope that helps